Hey everyone, Dr. Chuck, and back with today's episode of Refrigerant Checkup. I want to talk to you about a subject you may have heard about, maybe not, but you will be hearing about it in the future because it's very important for our industry, and that is immersion cooling. So what's immersion cooling? What's all the hype? Where are we going to see it? Why is it important? We'll get into some of those details today, and then as the industry continues to advance, I'm sure there'll be more updates that I'd like to provide to you. But essentially, it associates applications like artificial intelligence, advanced data centers, high-end computer processors, crypto, anything that involves a ton of computing power and generates a lot of heat, consumes a lot of energy, really needs to do a good job on thermal management, keeping those electronics cool so they can operate effectively, reliably, and efficiently. Well, it turns out just using standard air conditioning and blowing cold air is just not enough cooling force to remove all the heat that's being generated. So we're forced to really go to a new technology. And immersion cooling, like the name implies, the devices are immersed right in the cooling medium or the thermal management fluid, as opposed to generating cool air in a typical air conditioner or chiller and then using that cool air to remove heat from the electronics. To help understand why immersion cooling is so effective, I think it's useful to look back at an old example we used to use when we're trying to teach the difference between temperature and heat. Imagine setting your oven to a temperature of about 212 degrees and putting in some food to warm up or slow cook. While the air in the oven at a temperature of 212 might feel warm, the heat transfer is really minimal and it's not going to burn your skin if you reach in. However, think about a pot of water boiling at 212 degrees. It may be at the same temperature, but you would never put your hand in that water as the heat transfer is much higher and will result in severe burns. The difference here is really a difference based on the densities, heat capacities, or the ability of those fluids, a liquid versus a gas, to carry heat. So it really is the density of the fluid. Obviously, liquid water, a lot more dense, has a lot more capacity to carry heat than air, which is the gas. That's the same principle applied to immersion cooling. Of course, we're not going to use water because we're going to put electrical components in there. So it has to be non-electrical conductivity type fluid, but it has to have good thermal properties. So we have some really great Opteon products, fluids that have great properties. Other properties you're going to look for: materials of compatibility. You're going to want these things to stay pure and not degrade the things you're trying to protect. But if you look at some of the numbers, and we'll be sharing some of those in the future, and we have a lot of other material on our Opteon.com website around immersion cooling and our new 2P50 immersion cooling fluid, which is in development. But again, if you look at the benefits for the data centers, for the server farms, for all the operations in terms of reducing the energy required to do this thermal management, you can cool things a lot more efficiently, a lot more cost effectively with two-phase immersion cooling. You also reduce the amount of water that's consumed. Some of these places consume an awful amount of water. The physical footprint gets smaller, energy costs get smaller, total cost of operation. So there's a lot of important drivers that are driving the high-end computing industry and electronics thermal management solutions to something like two-phase immersion cooling. So I hope if you haven't heard of it, this gives you a little bit of an introduction. It's really cool. If you watch some of the videos and you see somebody dropping their cell phone into a fluid, it looks a lot like water, but it's not. It's got some really advanced properties. And we think it's really going to be an important, valuable solution as our industry continues to support a related industry and as we move towards digitation and other aspects of growing the digital economy. So to summarize, immersion cooling is an advanced cooling technique primarily used in data centers, high-performance computing, energy-intensive industries to manage heat more efficiently than traditional air-based cooling systems. With increasing demand for faster, denser computing power, the need for effective cooling has become critical. Immersion cooling involves submerging these electronic components, like servers and processors, directly in a thermally conductive but non-electrically conductive liquid, allowing for direct heat transfer from the components to the liquid. This approach effectively reduces heat load and enables better thermal management compared to traditional methods. What makes immersion cooling unique is its efficiency in managing high thermal loads and reducing overall energy consumption. Unlike traditional air conditioning, which relies on fans and ambient air to dissipate heat, immersion cooling uses specialized dielectric fluids that can absorb heat much more directly. These liquids allow for a high-density configuration and minimize the need for air handling equipment, making immersion cooling a more suitable and cost-effective solution, particularly in facilities where maximizing cooling efficiency and reducing energy costs are priorities. So thanks again for checking out this episode of Refrigerant Checkup. We'll continue to bring you breaking news on the immersion cooling applications and technology as it comes along, but it's something you should keep an eye out for. I think it's really interesting and something you may get involved in your job sometime down the road in a not too distant future. Again, thanks for supporting the Dr. Chuck Refrigerant Checkup channel. Any questions or any topics you want me to cover, give me a shout. Stay safe out there. Thanks. Have a great day.